Good morning, AWS Summit, and welcome to the 2025 Joburg Summit here in Joburg. Thank you so much for attending my talk. I know it's super early, but if you ask interesting questions, this is Mayday, and I might throw you with the Chaos Monkey. So, my talk today is Mayday. There's chaos in production. My name is Henry Francis. I'm an AWS community builder. I'm also a cloud and technology strategist with over 20 years of enterprise experience. I am also the founder of AWS Community South Africa, hosting Community Day next month. For social media, if you want to follow me, there's a lot of social medias, all the same tag. You can visit my website, and for the really lazy people, there is a QR code to scan, so feel free to scan it. So today we're going to ask the question, what is chaos? There is still a real perception of that is chaos will blow up your production today. But chaos engineering is not about blowing up production. It's a definition of the official open source principle of chaos engineering. States chaos is the discipline of experimenting with a system in order to build confidence within the capabilities of withstanding turbulent conditions in production. But if you take away all of the noise, you are left with a small sentence which forms a new word. Chaos engineering builds confidence in production. What does building confidence in production really means? How do we build confidence using your chaos in production? When we build, we need system recovery, and to recover faster in chaos engineering, it's not about how you bounce back in your system, it's rather about how you bounce back faster, quicker, and better, and much more smarter. It's also the ability to scope out and limit your blast radius, and have the ability to reflect and roll back much quicker in your system. We also need to protect our user experience, which is really important. Safety is really non-negotiable in this day and age. The test, we test without guardrails, rate limit things just to kind of recover quickly. But then, if we don't monitor our system and it breaks and you don't know your dashboards, and you don't have visibility, what are you monitoring? You are only having wishful thinking in your systems. In chaos engineering, observability is not optional. It turns your chaos into insights. So now the question is, why the hell do I want to test in production? That's scary. Well, it's fairly simple. It's where our users are. It's where revenue flows and where failures have the biggest impact today. A broken staging environment is an inconvenience. We can deal with that. But a broken production environment really gets some insights and really attention to it. And then no amount of staging or QA testing is perfect. It's unpredictable and messy and beautiful. But today, we want our staging environment to be equal to our production environment, which is not always the case. If you are really too scared to test in production, are you then really resilient? The question would be, if you say you are DR ready or you are resilient and you're not comfortable to test in production, then you are not DR ready. You don't trust your systems and you don't trust your processes. So then, why is it needed? Why do we do chaos engineering? It is needed to ensure we are resilient. That is the goal of chaos engineering. By identifying our weaknesses in our systems, you are able to know what to improve. If you don't know what's broken, how can you improve it? Then, by raise of hands, and I want to be honest, whose staging environment is exactly like for like, config for config, the same as production? There's one. Oh, obvious. So that is really important, to have your staging environment exactly the same as your production environment. Otherwise, you're going to get false positives and not test really accurately. But staging is almost never a true reflection to what production environments are. It's difficult and it's very costly to have that. And that can also be a very problematic for testing. As systems scale, the complexity grows, and with complexity grows, the systems interact in unexpected ways, which makes it very unpredictable. In real world events, that is a true event and a true recipe for proper chaos. Testing and staging is great, but it is not enough. If you ever worked with distribution systems and is known for their complexity, being really unpredictable, you know the complexity and you know the dangers of not having a true test in your distribution system. But failing when you touch, sometimes it will fail when you touch something, otherwise it will fail when you don't touch something. So then comes the question, I haven't touched it, but it broke, but yet I touched it and it broke. So either way, it will break. So creating a cost-efficient failover plan that will save you money in the event of the failover, that is also why it's really needed. You don't want to spend too much on your resilience and leave out your production environment. So, going over engineering steps. There is a very scientific approach to this, and we are taking steps to ensure that we are setting this up for success. It's called steady state. It's step number 1. It means your workloads are testing under what you call normal, and your operational parameters is kind of set to a certain value. There's high-level top metrics for like payment systems. You will say transactions per second or things like that. So it's kind of your measure of success. But when you say my system will remain in a steady state, because I designed mine in a steady state way, my system will remain operational within the operating parameters. And if you didn't design your system in that way, you are not ready for chaos engineering. That is really, really important. You need to design your systems to be chaos ready. So when you moving on to a hypothesis, you need one, because it's kind of the bad thing that will happen. It's kind of what you test for. And with your hypothesis, things like EC2 dies, a network link goes down, AZ goes down, things like that. That's our hypothesis. It's something bad that goes down. So, based on previous experiences, a typical hypothesis could be at a rate of, let's say, 100 transactions per second, 80% of my nodes group are terminated, and then the API continue to serve the 99% percentile under the 10 millisecond response rate. That's kind of a steady state for my scenario, right? So then also I will say my EKS will recover, the nodes will auto recover in 5 minutes, and then pod scheduling will start processing traffic within 8 minutes, and after the experiment is completed, and obviously my alerts will fire. That is part of my hypothesis. And then we design experiments to reflect real world events, like service crashing, drives malfunctioning, and for all the crowd over here, everyone will remember the nice blue screen of death from XP back in the day. So learning about how your system behaves and observe the findings is the chaos test. That's what you are testing. And then you went out of your defined parameters, you did not maintain a steady state, you need to improve, and that's kind of the SDLC of chaos engineering. So after you test, you start again and run through all of the steps until you test again, and it's continuously. Ideally, you want to build it in a sort of a pipeline, so each time you commit code, it runs a chaos engineer test for you. That is where you want to be. So you improve by redesigning in your final steps, applying your best practices and using the reliability pillar to run it again and again and again. That's kind of where you want to be. So until the hypotheses are confirmed and you are truly back to steady state, or your steady state redefines. So there's a different few forces of chaos that can be used to do chaos engineering. We can introduce these different forces to test different scenarios. And the most important, or the most popular one, would be graceful restarts and derogations. That's the first one, better known as Chaos Monkey. So I believe that is very relevant. Chaos Monkeys, have you turned it on and off again? It works, yes, move on. So Chaos Monkey is obviously developed by Netflix. It simulates failures in production environments, and it randomly terminates VMs and containers. That's the kind of the purpose of Chaos Monkey. But then you get targeted chaos, that you target a very specific thing. You are testing for one thing only. You're not testing a whole environment, you're testing a very specific thing, like a regional failover. Think of ways how tech can fail and test for that very, very specifically. Then cascading failures is also a very popular one. It's where one service fails because of another service that fails, and this causes another service to fail. That's the domino effect of cascading failure. Because one service fails, the other one will fail. Either upstream or downstream, it doesn't matter, it still will fail. But we need to come to a change in where we are in our engineering, in environments and cultures. We need to get to a state where we ask the question not if it fails, but when it fails. That is kind of where the good place you want to be when introducing chaos into your environment. Like, you know it's going to fail, but when it fails, this and this will happen. That's kind of where you need to be in the area. So because of this changing culture, we can then experiment with things differently. There's a mind shift in the engineering perspective of how you test and why you test it. That's where you can start to be able to play around with fault injections and specifically targeted points in your system that fails, where each team can introduce fault injection into their own system because they are comfortable enough to understand that. But how can we start introducing this? Where do we go? And a great example of this is game days. Game days are designed for this. There's a lot of game days, and there's a lot of partners today that has really, really cool chaos engineering tools that you can leverage today. So by planning your scenarios, game days needs planning. You can't just wake up the morning and say, hey, I want to do a chaos engineering test. You need to start planning for these game days. You need to identify the issue you want to solve. You need to identify the test you want to run, and you need to identify the ideal outcome you want to do. So that is abnormal situations in your applications that is facing or expecting some form of weird response. That's where game days comes really in. Then when you run, you execute the plan, and then you take this plan and note the unexpected behaviors, the weird things. You take the post-mortem, you list the actions, and then after the game day, you address these actions in an orderly manner. As we said, post-mortem, just address all of these items after the game day, and then plan on the next game day. And each game day, it will become easier. So there's a list of tools that you can use for game days, for chaos engineering. And one of these tools, harness, they are at the back of the expo area. They have a brilliant chaos engineering tool. There's a lot of open source tools you can use. Harness do have an open source tool. There is also a paid version, so feel free to go chat to them. They have a really great team that are on here, and I do believe the chaos engineering guys will come a bit later today. So I'm also going to head that way. So I'm going to start ending off. The biggest challenge today to start chaos engineering, and it's regardless of the industry, regardless of the company, the biggest challenge we face today to implement chaos engineering is executive buy-in. If you get your execs to buy into chaos engineering, you won 90% of the battle. So get your executive buy-ins today, get them on and understand how chaos engineering works. They don't need to know the details, but they just need to know the value of chaos engineering, and you'll get far with your operations. So to end off, there's a lot of resources on the Builder Center. It's the go-to place for anything to build, connect with the AWS community. There's a lot of different environments that is in the Builder Center. It provides seamless experiences for discovering communities like these. There's published articles, and everything is open for you guys to use. By submitting product improvements, that is also done through the Builder Center. So that is a really great resource to use for your engineering purposes. So then come join us today with millions and millions of users learning and certificate, writing exams, skilling up, learning about all the technologies today. And without the technology, innovation is not possible today. But it's people will build the time that will make the tomorrow better. And so yeah, the time is now. Thank you so much.